Let's solve lots of ESAT and PAT mathematics practice questions. We're going to start off with a paper from the ESAT, but the questions are fully applicable to the PAT as well. So we have this expression involving square roots, and one of my pieces of advice would be as soon as you see a root 12, you can make things normally substantially easier by simply representing it as 2 root 3. So what is that going to give me? 2 root 3 plus root 3, all of it squared, and then we're going to get at the bottom of the fraction 2 root 3 minus 2 root 3, all of it squared. Okay, well, this here is just going to give me 2 root 3 plus root 3 is just going to give me 3 root 3. All of this is squared. Divide that by root 3 squared, which is just 3. This here is, of course, just going to be 9 multiplied by 3 divided by 3, giving us just 9. Correct answer is F. Okay, question 2, solve fully the inequality. So if we have 2x squared needs to be greater than 15, take away x. One of the things that we need to deal with inequality would be to aim to actually sketch the quadratic. Well, what sort of a quadratic is it actually going to be? Well, it's 2x squared plus x, take away 15. This is the quadratic that we're going to be dealing with. I don't think this here is factorizable, so we're going to have to find the 2 roots using the quadratic formula. In other words, this here will be minus 1 plus or minus the square root of minus b of b squared, which is just 1, isn't it? Yes, so it's going to be 1 squared minus b, which is 4 times 2 times by minus 15 divided by 2a, which is 2 times 2, so it's going to be divided by 4. Okay, well, this here will then be equal to minus 1 plus or minus. Let's do this slowly. It's going to be 1 plus 8 times 15, which is 120. Notice how the 2 minuses have given us an overall plus sign. And then we're going to be dividing that by 4. Okay, so root 1 is going to be minus 1 plus the root of 121, which is just 11. Divide that by 4. So this here is just going to give us 10 over 4, which is 2.5. x2, on the other hand, is going to be minus 1 take away 11, so that's going to be minus 12 divided by 4, giving us minus 3. Okay, so now we know what the quadratic looks like roughly. We're only really interested in the roots. So one of them is at minus 3, the other one is at 2.5. The quadratic does sort of something like this, and we want the this here to be greater than or equal to 0. So in other words, where is this quadratic actually not negative? Well, why is that actually? Because if in the original inequality, if we go back here, this here would have been equal to or greater than 0. So we want this region over here, and then we want this region over here. So x needs to be equal to or less than 3 and greater than or equal to 2.5. Correct answer is E. Okay, a little bit of rearranging. So what we need to do is simply rearrange this for x. Okay, well, let's do this just step by step. So I'm going to go x over 2 minus 1 squared is going to be equal to y plus 5, and then divided by 3. Okay, now we're going to square root everything. Then we're going to go x over 2 minus y is going to be equal to plus or minus the square root of y plus 5 divided by 3. X over 2 is going to be equal to 1 plus or minus the square root of all that. If we were to multiply this by 2, then what we're going to get is that this here will become a 2, and then we're going to get another 2 added up here. I think this here actually corresponds to an answer. Looking at it, seems to be B. 4. Fruit stall sells apple costing X pounds each and pears costing Y pound each. Okay, Sam bought 2 apples and 5 pears, and total cost of these was P pounds. Okay, So 2 apples, I'm going to say 2 of A plus 5P is going to be equal to the total cost. Okay, Leslie bought 3 apples and 2 pears, and the total cost of these was Q. So I'm going to say that 3A plus 2 pears, that here is going to be equal to Q. A lot about these problems are just translating them to algebra, essentially. Okay, what are we looking for? The price of a pear. Okay, so we've got a system of equations. This probably is an easy way of dealing with this. What I'm going to do is I'm just going to say that the variable a here, what is that going to be? It's going to be equal to p minus 5p, divide that by 2. Then I can plug this into the second equation, and then I'm going to get 3 times a, which is p minus 5p, divided by 2 plus 2p is equal to q. Okay, now it's just a question of doing a bit of rearrangement. So 3 over 2p, take away 15 over 2p plus 2p is equal to q. Okay, 3 over 2p, and then let's say take away q, bringing all the lowercase p's on one side. We're going to get, what is it, 15, take away 4 over 2. I'm skipping one step over here, or let's make sure that this here is a lowercase p. But basically what I've done is I've brought this over onto this side, giving me 15 over 2, and then I've taken away the 2p, which is turned into 4p over 2 underneath a common denominator. Okay, I can just rearrange for p now, which is going to be whatever's left on the other side. And then we're going to multiply this by 15 minus 4 is just 11, so 2 over 11. Okay, well, this here means that p is just going to be, well, 3 p over 11 minus 2q over 11. This here almost corresponds to an answer, just a slightly different form, but correct answer is G. P is directly proportional to q squared. Okay, when p is 2, q is equal to 4. Q is inversely proportional to r. Okay, well, let's just convert this to an equation. So I'm just going to say that p is equal to kq squared. With this information, I can immediately work out what k is, because k is just going to be p over q squared. So this means that it's going to be 2 over 4 squared, which is 16. So this here is just going to be just an eighth. Okay, then we also know that q is inversely proportional to r. So this means that q is equal to some other constant, let's call it k1, divided by r. So can we work out what k1 is? Well, we're given some numbers. When q is 2, r is 5. So that means that k1 is equal to q times r, which is 2 times 5. So this here is just equal to 10. Okay, now let's go back to this equation. I'm going to say that p is equal to k q squared, which is equal to k, and q was just equal to k1 over r1 squared, which means that this here p will just be equal to 1/8 multiplied by 10 squared over r squared, which is the same as 100 over 8 r squared, which is the same as 25 over 2 r squared, which corresponds to the correct answer being E. Question 6. Two sequences are defined by the following rules. If the sequence S, the nth term, is 7 plus 1, the sequence T, the nth term, is 99 minus n squared. What is the smallest value for n for which the nth term of the sequence is greater than the nth term of the other sequence? Okay, so this here looks like a sequences problem, but in reality it seems to be just an inequality. Because if we word this carefully, if we read this carefully, we just see that 7n plus 1 just has to be greater than 99, take away n squared. Okay, so what does that mean in practice? Let's just tidy this up a little bit. 7n plus 1, take away 99, plus n squared has to be greater than 0. N squared plus 7n minus 98 has to be greater than 0. This here is just the standard sort of inequality. We can actually factorize this, which is just going to be equal to 7, and then we need a plus 14 over here. This needs to be greater than 0. Okay, well, we're going to have this quadratic. It's going to have roots at negative 14, and then it's also going to have roots at plus 7, but it needs to be greater. It's not equal to, so we can't use 7, and then our answers need to be distinct positive integers. So 8 is going to be the next one, which actually works. Correct answer is C. Some of you guys might be thinking, well, why is it not sort of minus 15? The reason for that is because we're talking about a sequence. So typically in a sequence, we tend to start the sequence from n is equal to 0, 1, 2, 3, looking at positive integers only, not necessarily the negative ones. Okay, question 7. Which one of the following is a simplification of the following expression? Okay, let's simplify this a little bit more. So the first thing we can do is just kind of do that and get rid of some x's. Right, so what do we get? We get that this thing here is equal to 2 minus 9x squared minus 4 over x, 2 minus 3x. We can probably then use the fact that we have a difference of squares just above. So this here will just be equal to 3x minus 2 multiplied by 3x plus 2 upstairs, and then what we're going to have left is x 2 minus 3x. Now we're just going to be quite a bit careful. We're going to take a factor of minus 1 out of one of these, because then that will allow us to cancel the bit below. So this here will be 2 plus 2 minus 3x, and then we can just copy the rest. And then notice how the 2 minus 3x will just end up cancelling out. So what are we going to be left with? We're going to be left with 2 plus 1 over x multiplied by 3x plus 2. We can simplify this even further by just saying that this here will just be equal to 2 plus 3x over x, which is just 3. So it's going to be 5 plus 2 over x. Correct answer is D. Okay, we've got OPQR labeled clockwise is in the first quadrant with O at the origin. The point R has coordinates 3/2 a 0, and the point Q has coordinates 2a a plus 1. And the area of OPQR is 9 square units. What is the coordinate of point P? Okay, so with those geometry problems, what we want to do is we want to get a sense of what we're actually given. So the first thing we probably want to do is draw a little coordinate system. First point is O. That's quite easy to plot because that's just at the origin. The next one that we want to plot is probably R. So that's going to be at 3/2 a. So let's just say that that's around here somewhere. And it's at 0. We also know that we have another point which is Q that has coordinates 2a. So 3 over 2 is 1.5, so 2 is just going to be a little bit sort of further up. And this here is just going to be Q, like this, because it's at a plus 1. Let's call this point a plus 1 over here. Okay, well, what will our figure actually look like? It's going to look something like this. And we just need our coordinate for the very last point over here. Well, we know that if this here is 2a, then this distance here is going to be the same as, well, this distance here, which is going to be 1/2. So this here is going to be 0.5a. And we know that it must lie at the same height, which is a plus 1. So the coordinates of P really are simply going to be 0.5a or half an a, and then a plus 1. So in order to answer the question though, we really need to know what a actually is. And we can determine that because we know that OPQR is 9 square units. Okay, what is the area? Well, the area of this shape, even though it's not a rectangular one, it's still going to be just base times height. So 9 is going to be equal to the base. Well, what is the length of the base? From here to here, we have 3/2 a multiplied by the height of it. Well, the height of it is just going to be a plus 1. We have 18 is going to be equal to 3a times a plus 1. And then what does that mean? That means that let's say that 6 is going to be equal to a squared plus a. So that's going to be a squared plus a minus 6 is equal to 0. This factorizes to a plus 3, a minus 2, like this, which is equal to 0. Now, let's take the positive root in this case, because those distances need to be positive. So a is going to be 2. Okay, if a is 2, then the coordinates of p are simply going to be half of a, which is 1, and then a plus 1, which is just 3, meaning the correct answer is B. Question 9. What is the value of x that makes the following expression correct? And we're given an expression over here. Okay, I'm just going to switch to blue just so that I want to keep the previous working also there. So we have 2, 4, 8. What's common between those two problems? We can probably express them as basis of 2. What do I mean by that? So if the first one is 2 raised to the 3 to the 2x, then the second sort of factor is going to be 2 squared raised to the x, which is going to be 2 to the 2x, multiplied by 2 cubed raised to the minus x, which is going to be 2 to the minus 3x. So this whole thing is just equal to 4 root 2. Okay, well, let's just simplify this a little bit. We're going to get 2 to the 3 plus 2x, 2 to the 2x minus 3x. So that's going to be, those two are going to give us 4x minus 3x is just going to give us x. So this here will just be 3 plus x is equal to 4 root 2. Tell you what, let's just get rid of this square root. So I'm going to square everything. So I'm going to go 2 to the 2, 3 plus x is going to be equal to 4 squared is 16 times 2. This thing on the right hand side is just 32. So this means that 2 to the 3 plus x is equal to 32. I'm sure there was an easier way of solving this, but this is the first way that I actually spot it. So 32 is equal to 2 to the 5, isn't it? So because of that, we can just say that 2 raised to the 3 plus x is going to be, or 2 multiplied by 3 plus x is going to be equal to 5. 6 plus 2x is equal to 5. 2x is going to be equal to minus 1. X is going to be minus 0.5. Correct answer is D. 10. There are 100 students in year 10. Each student studies exactly one of these: French, German, and Spanish. X girls study French, and there are 3 X girls in total. 2 Y boys study German. There are 35 students studying Spanish, of which Y are boys. Okay, we're looking for an expression. So the best way to do these is with a table. So let's have French, let's have German, and let's have some Espanol. And we're going to split it like that. So we will have girls, and then boys along here. Okay, so what do we know from the problem? We know that X girls study French, so we can put a little X here. We know that 2 Y boys study German. And okay, we know that there are 35 students studying Spanish, of which Y are boys. So that's going to be this many boys studying Spanish, which means because there's 35 in total, we're going to have 35 minus y girls studying Spanish. But because there's 3x girls in total, that means that the amount of girls studying German will just be 2x minus 35 plus y. What I've done over here is I've just done 2x minus this and then just expanded the brackets to give me a plus here. This here actually answers the question directly, luckily for us, so correct answer seems to be F. K11, an exterior angle of a regular polygon with sides n is 4 degrees larger than the exterior angle of a regular polygon with n plus 3 sides. Okay, so the exterior angle formula says that for an n-sided polygon, we have the angle, the exterior angle is equal to 360 divided by n. And then we know that the other one is that this one here is 4 degrees larger, isn't it? With n sides 4 degrees than the exterior angle of a regular polygon with n plus 3 sides. So this take away 360 over n plus 3 is going to be equal to 4. Okay, this here looks like it's going to be an inequality or an equation. So what is that going to be? Is there an easy way of solving this? Probably not. If you find one, do let me know. Let's put these underneath a common denominator. So I'm just going to do 360. I'm going to say n plus 3. Take away 360. Multiply this by n. What is that going to be? That would be 4n n plus 3. Okay, so 360n plus 3 times 360, take away 360n, it's going to be equal to 4n n plus 3. Okay, some of these are going to cancel out, which is nice. What is going to be left? We're going to have 3 times 360. I'm still hoping that something will cancel out. Oh, I've got a 4 here. Yeah, let's cancel that in a second. So 4 over 360 is going to give me just a 90. So it's going to be 3 times 90, which is 270. Is going to be n plus 3. Okay, so now this here is not going to be very nice to solve, but let's see if we can be smart about it. So we want something which, a number, which if we square, but not quite square, we add a little bit more. So it's not just like, let's say, I don't know, it's not 10 squared, it's multiplied by n plus 3, which is 13, which is going to be bigger than that number squared. Now this thing has to equal 270. So all of these numbers starting with a 2 are just going to be way too big because the answer is just going to be bigger than 400. 18, yeah, so 18 times 18, that will also be a little bit too big. So 10 on the other hand, because 10 times 13, or we can actually just calculate that, that's just 130. So this here is going to be a little bit too small. 12, I suspect, is also going to be too small, but 12 times 15, is that 180? It's too small. Correct answer has to be C. And yeah, 15 times 18 is 15 times 15, which is 225 plus 45, which is indeed equal to 270. Okay, question 12. The bearing of a ship R from a lighthouse L is 220. Now, the thing to watch out with these questions is, number one, the actual wording, and then to make sure that we've drawn a really good picture. Okay, so let's draw a little coordinate system. Let's make a little bit of space. I'm just going to place that here. And at the center of that coordinate system, I'm just going to place L. Let's just double check the actual wording. Is the bearing of R from L is 220. So if L is here, there's going to be an angle of 220 degrees to the north. So this whole angle here is 180, meaning that we need to go another 40 degrees to reach R. Okay, so let's draw that. Now C is due north of R, and C is the same distance from the ship and the lighthouse. So if I was to essentially place C, it's be somewhere here, directly due north. And it's going to be such that, maybe I'm just going to place it a little bit closer to here, that this distance here is going to be the same with this distance here. So So if this here is C, that distance is the same as this one. Okay, now let's just be careful a little bit about the angles. This here is going to be equal to 40 degrees. Notice how these here, like this angle here and this angle here, are actually going to be the same because they are just Z angles. So this means that this one here is also going to be 40 degrees. So they need to reach 90 degrees. So this means that this here angle will be 10 degrees. And what is the question actually asking for? What is the bearing of L from C? Okay, so if we were to place a coordinate system on C, the bearing of it will just be the angle that we need to go past from north. So if this one here is 10, this one here is going to be 90, this one here will be 80 degrees. So correct answer is going to be B. Question 13, the hands of a 12-hour analog clock move continuously. Okay, when the time on the clock is 4 o'clock, the angle between the minute hand and the hour hand is 120. What is the angle between the two hands at 4:40? Okay, so these things are typically solved by drawing a little diagram, but also figuring out essentially the angular speed of these two clocks. So, okay, now at 4 o'clock, what is it going to look like? We're going to have one of the hands over here, the minute hand, and the other hand is going to be at 4 o'clock, which is somewhere over here, and the overall angle is going to be 120 degrees. Okay, then this here is at 4. At 4:40, both of these will have moved. Now the minute hand will have moved quite a bit to at 4:40. It's going to be somewhere here just underneath 9. So let's say this here is the minute hand. And then the hour hand will no longer be at 4, but it's going to be closer to 5, somewhere roughly around here. So the question is, what is this angle here going to be? I prefer to think of these problems in terms of the angular velocity. What do I mean by that? So let's work out the speed of the minute hand. And that's going to be in terms of angles or degrees per minute, because this is a far more natural way of thinking about it. So it's going to cover 360 degrees in 60 minutes. So that's going to be 6 degrees per minute. On the other hand, the speed or the angular speed of the hour hand, well, that's going to just be 360 degrees, and the hour hand is going to go back to its original position in 12 hours. So that's going to be 12 times 60, which is going to be 360 over 720, which is what? It's half a degree per minute. Okay, now in 40 minutes, obviously in the real exam, don't write as much detail, but this is just a way to show you exactly what I'm doing. How much will the hour hand travel? Well, the hour hand will travel 40 multiplied by half. So 40 multiplied by half, which is 20 degrees for the hour hand. What about the other one, the minute hand? Well, that's just going to travel 40 multiplied by 6. It's going to be a lot more. So what is that? 240 degrees for the minute hand. Okay, well, the minute hand was originally here, so that means that it will have gone sort of over here at 240 degrees, whereas the hour hand would have gone from 120 to 140 degrees because it would have traveled 20 degrees. So that means that the difference between them is going to be the difference between 240 and 140 degrees, which is just 100 degrees. So the correct answer should be B. The cost of manufacturing a cake is directly proportional to the volume of the cake. Oh great, now I feel like eating a cake. The baker makes a 70% profit when he sells a large rectangular cake. The baker sells a large rectangular cake for $6.80. Okay, we're looking for the profit and cost. Now there's a little bit of a trick with those over here. So if they make a 70% profit, that means that the price is going to be essentially 170% of the cost. So what does that mean? That it means that the price is going to be 1.7 times the cost. So this means that the cost will be the price. Divide that by 1.7. What is the price? It's 6.8. Divide that by 1.7, which is a nice number. It's just going to give us £4. Okay, so this here is the actual price. The baker decides to sell smaller rectangular cakes. The length, width, and height of the smaller cakes are off half of those. So that means that the cost should be halved, theoretically, 3 times. So that means that we're going to get 4 times a half times a half times a half, which is going to be 4 divided by 8, which is just going to be 0.5 or half. Okay, so he sells a pack of 6 of the smaller cakes for $6.50. How much profit does he make on the pack of the smaller case smaller cakes? Okay, so what we need to do is just essentially work out the cost of them. So because there's 6 of them, so it's going to be 6 times 0.5. So the overall cost is just going to be 3, meaning that the profit is just going to be the total price, which is going to be $6.50, take away 3, giving us a profit of $3.50. Correct answer is D. Question 15. A pet shop has 4 female rabbits and X male rabbits for sale. Customer buys 2 of the rabbits chosen at random, and each rabbit is equally likely to be chosen. Probability that both the chosen rabbits are male is 1/3. What is the value of X? Okay, so a pet shop has 4 female rabbits and X male rabbits. So that's going to be a total of X plus 4. We can say that the probability of the first one being chosen to be male is just going to be X over X plus 4. Then we're going to multiply this by the probability of the second event, which is going to be 1 less left, so X minus 1 divided by X plus 3, and that overall probability is going to be equal to 1/3. We've just multiplied the probabilities of the 2 events. Okay, so this is going to end up being, shall we just multiply everything out, and we can say that this here will be 3. Let's say X multiplied by X minus 1, and then I'm going to bring X plus 4 and then X plus 3 onto the other side. Okay, what is that going to give us? It's going to give me what is it? 3x squared minus 3x is equal to x squared plus 7x plus 12. Let's tidy this up a little bit. So it's going to be 2x squared minus 10x minus 12 is equal to 0, which is going to be x squared minus 5x minus 6 is equal to 0, which is factorizable. So it's going to be x minus 6, x plus 1 is equal to 0, meaning that x is just going to be plus 6, and we're going to ignore the negative solution. So we're going to get C, the correct answer. Question 16. The diagram shows a square with side length of length x centimeters. A circle is drawn with center O, which lies at the midpoint on the sides of a square. A side forms part of the diameter of the circle. Circle passes through 2 corners of the square as shown. What is the area in centimeters squared of the shaded part of the semicircle? Okay, so the way we do this is always by subtracting areas. Probably the first thing that I want to do is just work out the radius of the square. So the radius of the square, for instance, is just going to be this distance, right? Let's call it R, and we know that this distance here is just x, and this here is just going to be the midpoint, so that's just going to be x over 2. So we can work out the radius just using Pythagoras. We can just literally say that the radius is going to be the square root of, one side is x squared plus x squared over 4, which is x over 2 squared. Tidying this up a little bit, what is that going to give me? That's going to be 4x squared plus x squared, so over 4, well, all of this divided by 4, that's going to be root of 5 over 4 x. Okay, now I think we're ready to subtract the areas. Let's just be careful because this here is the area of a semicircle, so it's going to be pi r squared over 2. It's going to be the area of the semicircle, take away the area of the square, which is just going to be x squared. So this here is going to be pi. Now r squared is just going to be multiplied by 5 over 4, and then we get a factor of x squared, and let's not forget the factor of 2, take away x squared. This here is just going to give me 5 pi x squared over 8, take away x squared. At this point, we can pretty much inspect the answer, and we can see that this here, if we were to multiply this by 8 and then divide by 8, what we're going to do is get F to be the correct answer. 17. A cylindrical hollow metal pipe is 16 centimeters long. It has an external diameter of 10 centimeters and an internal diameter of 8 centimeters. The density of the metal from which the pipe is made is 8 grams per centimeter. Okay, we're looking for the mass of the pipe. So every time I see mass and density, I tend to just write mass is equal to density, multiply this by volume. So given the density here per cubic centimeter, so all I need to do is work out my volume in cubic centimeters. So it's going to be the volume of this shell here. So that's going to be the bigger volume, which is going to be pi r squared, which is going to be pi multiplied by 10 over 2, which is 5 squared, multiplied by the length, which is 16, take away the smaller volume, which is going to be the volume of a cylinder, which is pi r squared, pi 8 over 2, which is 4 squared, multiply this by 16. Okay, this here will just then give me 16 pi, and then we're going to have 25 take away 16, which is going to be 16 pi, multiply this by 9. The mass, that's just going to be density multiplied by volume, which is going to be 8 times 16 pi times by 9. Looking at these numbers, what is that going to give me? 128 pi, multiply this by 9. And we don't need to get the final answer, because if we multiply the 128 pi by 9, the only answer which makes sense is actually going to be G. Question 18. The shortest distance between two opposite sides of a regular hexagon is 12 centimeters. Find the area in centimeters squared of the regular hexagon. Okay, so the key here is to work out what we are actually given. So what do we mean by the shortest distance between two opposite sides? Well, that's actually going to be this distance over here. Okay, so every angle is going to be 120, and if we go from here to the actual center of the hexagon, we are going to get, let's assume that this here is the center, we're going to get a 30, 60 and then 90 triangle. In a 60, 30, 90 triangle, well, it's really useful to remember that if this here is 90, this here is 30, this side here is x, then the longest side is going to be 2x, and then the other x is going to be x root 3. So let's call the side of this S. That means that this side here to here is going to be s over 2. That's going to make this side here s over 2 root 3, which is going to make the whole distance over here. Let me just draw that in blue maybe. This entire distance is going to be equal to, well, s root 3, because it's just double that. And this is equal to 12. So this is going to allow us to determine our side. So we can say that our side is going to be 12 over root 3. Now let's just multiply the top and the bottom just to get rid of the square roots. We're going to get 12 root 3 divided by root 3 times root 3 is just 3, which is just going to give me 4 root 3. This here is going to be the side. Now, the next step is just to remember the area of a hexagon. You can derive that pretty easily just by looking at 6 equilateral triangles. But the area is just going to be 3 root 3 over 2. Occasionally you get questions involving that. It's just the sum of 6 separate areas. And if you forget this formula, you can derive this pretty easily. Okay, so this here is just going to be 3 root 3 over 2 multiplied by s squared, which is going to be 4 squared times root 3 squared, which is going to be 16. Multiply this by 3, which is going to be 3 root 3 multiplied by 8. Multiply this by 3. 8 times 3 is 24. Multiply this by 3. That's going to give me 72 root 3. Meaning the correct answer is E. And let's solve some path mathematics questions as well. We're going to start off with an easy one. We have a seed packet containing 100 seeds. When planted, 75 become plants. Okay, so we start off with 100, then we're left with 75, but only a third of these will have flowers. So 1 over 3 times 75 is just 25. And out of these, only 1/5 will produce fruit. So that's just going to end up with 5. Correct answer is A. This one here was not too bad. The next mathematics question I find quite tricky. What is the next number in the sequence? Let's inspect it first of all. Notice how the numbers are going 1 over 5, 3 over 25, 7 over 25, but then the numerator decreases back. The denominator as well is quite interesting. So we start off with 5, then we go to 5 squared, then we go to 5 to the power of 3, which is 125, then we remain at 5 to the power of 3. So there's something interesting going on in that term, and then we reach 3125, which is actually 5 to the power of 5th. Okay, so how are we going to deal with this? Well, if you think about the numerator, that goes 1, 3, 7, 3, but then it just kind of jumps into 31. So the numerator in the sequence is actually given by 2n to the power of -1, but then we're going to need to divide it by some function of n. So if we were to actually divide this by 5 to the power of n, this will work. Shall we just double check this? Essentially, we want something where for the first 3 terms, after the first 3 terms, there's going to be a shift in the way this thing is actually growing. So for n is equal to 1, we're going to get 2, 1, take away 1 over 5, which is just 1 over 5. That checks out. N is equal to 2 is 4 minus 1 over 25, which is going to be 3 over 25. N is equal to 3. So 2 to the 3 is 8, take away 1 is just going to be 7. Divide that by 5 to the power of 3, which is 125. So far, so good. N is equal to 4 as well, which is going to give us 16, take away 1, which is just going to be 15. Divide that by 5 to the power of 4. So this here will then provide some division. So what is that going to be? 5 times 3 over 5 to the power of 4. So this here is just going to be 3 over 125. You can do that check for n is equal to 5 as well if you wanted to. It does work. It does end up giving us 31, because 2 to the power of 5 take away 1 is just going to be 31 divided by 5 to the power of 5, which is 3125. The easiest way to select the next one is just to consider the numerator, because we're going to have 2 to the power of 6 take away 1, which is 64, take away 1, so the numerator must start off with 63. So therefore the correct answer is E. Next one, we have a function which is equal to x squared. You want to transform the function so that you get a new function which is stretched by a vertical scale factor of 2 with a line of symmetry x to the power of 1 and which is never positive. So you don't want this to be positive. Okay, so let's just take this one by one. We want our line of symmetry to be around x is equal to 1. So I'm going to shift this up to x is equal to 1 just by saying that I'm going to take f of x minus 1. Okay, then what I'm going to do is I'm going to add a scale factor of 2 like this, and then I'm going to make sure that this function is never positive by putting a little minus sign across here. So this here corresponds to A, which is all of the correct transformations. If y is equal to 2 plus x squared over 4, which of the following is dy by dx? Now notice that this is something which is very possible but very tedious to actually differentiate, because you're going to have to do a lot of quite tedious algebra. There is a way of solving this much more efficiently. So what I recommend remembering about the binomial expansion is that 1 plus x to the power of n is about equal to 1 plus n multiplied by x, provided that x is smaller than 1, significantly smaller than 1. Okay, so that's going to allow us to predict the first couple of terms of the actual sequence. So let's just put that into this form. So I'm going to say that 2 plus x squared raised to the power of 4. So I'm going to get 2 and then 1 plus x over 4. This whole thing is raised to the power of 4. Okay, well this here will just give us 2 to the power of 4, and then I'm going to apply this formula to this expression, because now it's in this form that I can apply the binomial expansion. So this here is just going to give me 1 plus 4 times x to the power of 4, which is just, of course, 1 plus x. So this here is just going to be 2 to the power of 4 plus 2 to the power of 4x. Now, if we were to differentiate that, the first term is just going to be 2 to the power of 4, because after differentiation, this term is going to go because it's a constant, then x is going to go because we've differentiated that. So 2 to the power of 4 is 16, meaning that our first term must start off with 16, and the only one that fits the bill is D, which is the correct answer. The next one, if dy by dx is equal to x squared plus 1 over x cubed and y is equal to 0 and x equal to 1, what is the following integral? Okay, with this one here, I don't think there's too many tricks. We just have to, well, calculate it out. Y is going to be equal to the integral of x squared. Let's write this as x to the power of minus 3 dx. Doing the integrations, what are we going to get? We're going to get x cubed over 3, take away x to the minus 2 over 2, plus some constant of integration that we'll be able to find out. Okay, now if this here is y, we know that when y is equal to 0, then when x is equal to 1. So this here is going to be equal to 1 over 3 minus 1 over 2, because we're going to get 1 over x squared, which is 1 over 1 squared, okay, plus the constant. So that constant is simply going to be equal to 1 over 3, take 1 over 2, take away 1 over 3, which is the same as 3 over 6, take away 2 over 6. So our constant is just going to be 1 over 6. Okay, now let's actually integrate y by dx between 3 and 1 to get, what are we going to get? We're going to get x over 4 and then 3 times 4 in the denominator, plus x to the minus 1. Notice how the minus changed to plus because I've divided by minus 1 over 2, plus, what are we going to get? The constant was 1 over 6. So this here is just going to be, because that was a constant, it will just be x over 6. And this here will be evaluated between 1 and 3. Okay, let's plug in the numbers carefully. So this here will be 3 to the power of 4 over 3 times 4 plus 1 over 2 times 3 plus 3 over 6. Take away 1 over 12 plus 1 over 2 plus 1 over 6. Okay, this is not a very pleasant algebra, but we'll deal with it. Okay, this here is just going to give me 3 cubed at the top, which is 27 over 4 plus 1 over 6 plus 3 over 6 is just 4 over 6. like that, take away, let's put everything in these brackets under a common denominator. So we're going to get 1 over 12 plus 6 over 12 plus 2 over 12. So this here is going to be minus 9 in total over 12. We have a 4, 6, and a 12. Putting these under a common denominator, which is 12, we're going to get 27 times 3 plus 4 times 2, take away 9, over the common denominator, which is 12. And this here is going to give us 80 over 12, which is the same as 20 over 3, which is hopefully an option. Correct answer is C. Okay, next one. What is an integer m such that the following sum 3 plus 2n evaluated between n is equal to 1 to the integer m is equal to 140? Okay, so the first thing we probably want to do is just split this sum. So that's the sum of 3 from n is equal to 1 to m plus the sum of 2n, n is equal to 1m, and the whole thing is equal to 140. Okay, so the first one is fairly straightforward. So this is just going to be 3 sort of added m times, which is 3m plus 2. Now the sum of n between those two integers, we're just going to apply the famous formula, m plus 1 over 2, if memory serves me right, which is equal to 140. Okay, so this here is going to end up giving us some sort of a quadratic. So this will be 3m plus the 2's are going to cancel. M squared plus m is equal to 140. M squared plus 4m is equal to 140, meaning that m squared plus 4m take away 140 is equal to 0. I don't think this is factorizable, so what we're going to do is we're going to take m, we're going to find the roots, m12. What is that going to be? It's going to be minus b, which is going to be minus 4, plus or minus b squared, which is 16, minus 4ac, minus 4, a is 1, c is minus 140, so it's going to be 4 times 140. Divide that whole thing by 2. This here would just be minus 4 plus or minus root 576 over 2, which is going to be minus 4 plus or minus, this square root is 24 over 2. Now we're going to take the positive root because we're talking about a sum, so all the terms we presume are going to be positive, so it's going to be minus 4 plus 24 over 2, which is going to be 20 over 2, which is just going to give us 10. Correct answer should be C. If you found this video very useful, I have yet another video covering some really important mathematics, which is really going to help you both for the ESAT and for the PAT right over here. Enjoy.